Here's comes question for you. What is the most abundant energy source in our solar system? It is 1 million is bigger than the Earth, and without it, our planet will be dark cold rock. You guessed it. Yes, you're right. It is an incredible sun. The Earth intercepts a lot of sunlight. It is said about 173,000 terawatt. Recent years, less than 2% of the world's electricity has come from solar power. Is it possible that the world could completely rely on solar energy? But with a new invention, it is likely to change that. Have you ever heard about Dssc or dye-sensitized solar cell? So actually, Dssc is a solid-state photovoltaic cell imitating the concept of plants' photosynthesis process.
So, how does the structure of the Dssc looks like? So, this is the structure of the Dssc. It is made up of glass consisting of ITO followed by the photoanode, which consists of TiO2, and then dye followed by the electrolyte, and then for counter electrode, which is platinum, and last but not least the ITO glass.
A photon enters the solar cell through anode, which is made up of wide bandgap semiconductor, which is TiO2. The dye molecule absorbs photons of wavelength corresponding to energy difference. The electrons from the ground electronic state of dye are transferred to excited state by the phenomenon known as photoexcitation of dye. This electron in the excited state of dye is injected to conduction band of TiO2. The electron from the conduction band of TiO2 are transported through the semiconductor by diffusion process and reaches conducting layer of ITO, also known as current collector. The electron can perform work and flow to the cathode through the external circuit where they can produce electrical power. Then, they re-enter through the cathode where they drive a reduction oxidation process in the electrolyte solution. Platinum is being used in commercial Dssc as cathode material. We are modifying the cathode by using Pani GO. The triiodide electrolyte gives the electron to the oxidized dye at anode and regenerates the dye molecule in order to allow the process to continue. The current flows through the circuit as long as the light falls on the circuit. Here is the history, limitation, and application of the Dssc. On 19th century, the Dssc was founded by Michael Greitzel, and on 2016, it shows that durability of the Dssc can up to 20 years. And recently, there is some drawbacks due to the low efficiency, and it can only be applicable to low power gadgets. Thus, our product is actually focusing on modifying the Dssc with a low cost and high efficiency. Pani and graphene oxide as counter electrode. Pani is low cost, high conductivity, and emphasizes synthesis. However, it has its own limitation in which experimental value of Pani electrodes are much lower than the theoretical value, which is lead to the cycling stability become lower. Why graphene oxide? Because it is high conductivity, large surface area, flexibility, and excellent chemical stability. However, it is easy aggregation of graphene lead to the decreased surface area and capacitance quality. But with these two elements is adding together, is actually complementing each other to be promising electrode, and our aim to produce the Dssc with a low cost and efficiency can be improved and at the same time can be achieved. The application of the Dssc actually can be integrated into low voltage devices. Make sure the photoanode is facing towards the solar source, and the voltage reading will slowly increasing. And after a few moments, it goes up to 0.6 volt. In order to light up one LED, which is required around 1.5 volt, we need another 3 Dssc. It's guaranteed that our project is successfully working. We believe through a further research, our platinum-free modified Dssc, which is less expensive and easy to fabricate, can be widely used in a low and high voltage devices.